All right. Good morning, folks. My name is Carl Matthias. I would like to thank Code PaLOUsa for this opportunity. I would like to thank each and every one of y'all be able to spend some time this morning and attend this talk. I'm going to talk a little bit about the challenges and the advantages that you have as an enterprise architect for building evolutionary architecture and what it really means and how that has evolved over a period of time. Um, there's just something brief about myself. As you can see, I am a very family-oriented person. I really enjoy spending time with my family outside of doing architecture work. I also work very closely on the associate board and technology committee for the Home of Innocence. It's an organization that's very well vested into the future of kids, and I really like to do the best I can and use my technology skills and fundraising skills for that organization as they are helping the community in general. A sports addict, love to play and watch sports both. Um, and so I do enjoy doing that with my boys as well, and in general with friends and rest of the family. All right. Moving forward, right? This is you probably see a few Dilberts here and there. It's just the way how I have enjoyed my life in putting a point across in a funny way. I really love them. So all of us have been guilty at some point of time to jump to solutions before understanding the real problem. I have been guilty on my side as well. On few occasions, have learned it over a period of time. It's always good to listen to the problem at hand first before you just jump into recommending solutions, right? So what is enterprise architecture and how it has evolved over a period of time? You will see that there is a common theme across here with term Agile and some of those things in terms of how software development lifecycle has evolved. So the perception of architecture being well defined upfront and not changing over a period of time has typically been the situation or been the condition where people say, yes, that's a sound architecture because it has not changed, and that means it has been pretty rock solid. But when you're challenged with not knowing all the requirements, and if the requirements have been evolving over a period of time, you can't have a fully defined upfront architecture, right? So you have a couple of approaches there. You basically are looking at emergent design, which is basically it allows for best architecture requirements and designs to emerge as the teams are self-organizing. However, it is a huge proponent of creativity. So a lot of fields like advertisement, media are using that very effectively. But in some of the cases where time constraint and cost is a huge consideration, and you want to kind of have a well-defined scope around it in terms of what your budget looks like and what your time horizon looks like, you really cannot delay the choices for the decision making. And also you can't deal with the cone of uncertainty and a lot of the unknown unknowns, right, which is very very well handled in the space of art and music and creativity. But it's a little difficult when it comes to engineering, right? So you have to be a little more pragmatic. So you still want to approach it in that creative fashion, but you want to kind of provide some kind of guidelines, right? Scoping around it. So that's why the term evolutionary architecture comes in, where it is an approach where you are driving incremental change in a guided fashion. But what do you guide the architecture through? So you have all these different dimensions that you typically are looking at outside of the functional business requirements that your business is putting forward. You're looking at, we have called this in the past technical requirements, but essentially they are dimensions of that need to be considered as part of architecture. So some of them are like you see on the screen: security. We're very familiar with security, very familiar with data, with all the other Privacy Act issues happening around California Privacy Act, GDPR. So you have the legal aspect of it. You're always talking about, okay, what is the performance of my system? How performant the system needs to be? How secure the system needs to be? And in the light of performance, as you are growing as a business, and if it is something that you are, you're striving for, you want your architecture to scale as well. So basically, how will your architecture adapt as the need is rising for it, right? Um, and last but not the least, like everything else, your system needs to be auditable. So basically, you need to be able to tell very easily who performed what kind of action at what point of time and for how long, right? So these are sort of I feel like they're the base dimensions across your architecture that are required in addition to the specific requirements of your business or for the business domain that you are supporting, right? So how do we measure that how do we measure this, and how do we know that we are evolving the architecture or guiding the architecture in the right way across all these dimensions? So the core idea out here is, talking about fitness functions. So by definition, a fitness function, if you think about it in mathematical terms or in terms of computation, it is something that determines whether an algorithm has improved over time. So you basically have an input into the algorithm or into the function, and then you basically have the output, and you're validating the output over a period of time. So time is a very critical component here, or you could say multiple runs of the algorithm, because what you're really checking is you're really checking the health of that aspect, right? You're trying to see, are you improving over a period of time? Are you staying the same? Are you actually degrading? So are you doing bad? If you're doing something bad, that means you're not guiding the architecture in the right way, and you need to take some corrective action. So that is sort of the high level aspect of the fitness function aspect. In terms of what you're looking at for each of these schemes, if we take an example of performance, something that we can relate very closely is if you were looking at, say, for example, a particular response time for a certain screen in your application, or a response time of a particular service, microservice, API, you basically have measured that performance over a period of time, right? And you know how it is performing now. So now you say, when you recommend a change to that architecture, whether you're evolving it from a data standpoint, whether you're reorganizing the interface contract for that API, you are trying to see whether it is still performing at that level in terms of the response time, in terms of the SLA, or is it not improving? If it's not improving, then you know that your fitness function for response time is basically going bad, and then you need to evaluate it and you need to make the corrections. Most of the scenarios are covered under testing for each of these fitness functions, which should not be a surprise to a lot of us. It's kind of similar to the software paradigm, how software development paradigm, sorry. But the key difference here is that there might be situations where everything cannot be automated. And in some cases, there might be manual tests that are needed. Like manual tests could be things like, if I'm looking at legality, I would also take into context some of the documentation that is needed, right? For talking about CCPA compliance and stuff, because all of this stuff, there might be some aspect of verification. So everything is not sort of like this automated testing code that is run against your requirements. Most of it is for many of these dimensions, but there are some dimensions like legality, I think, that comes across my mind, that would need you to have a process aspect of it and some documentation aspect of it to define the fitness function, right? So I've given some examples out here talking about which we are fairly familiar with. You're talking about automated tests, like unit tests, integration tests, functional tests, regression tests. We're talking about software development metrics like cycle time. We are looking at contract tests where you're looking at the health of the API contracts. You don't want to change the contracts very drastically. That leads to a lot of disruption. And the one that is, yeah, I won't say it's fairly new, but it's fairly challenging is the one around running experiments in production. An example of one of that is chaos engineering. I think one of the case studies I would refer y'all to would be what Netflix does as part of chaos engineering, right? So going into the details of this, in terms of the fitness functions, what you look at is there are different categories around it, right? So it's basically has the atomic aspect of it, where you're basically testing a specific functionality. So it could be like the unit test and the functional test. You're looking at aspects of maybe dependencies, anything related to, if it's related to code, you're checking for cyclomatic complexity. So those are some of the fitness functions, some of the fitness functions that you would define around and validate in the atomic world, because you're looking for a specific functionality. In terms of what you would do from a continual standpoint, but still atomic in nature, because that's kind of the time frame aspect of it, you would be looking at monitoring something in production or running tests against a particular contract, like health checks, API endpoint verifications, validations, anything related to open source library changes, things of that nature, right? Still very contained, atomic in nature, not going across the whole system or saying holistic in nature, but there is an aspect of it being triggered at a given point of time, which is a specific time horizon, versus doing something more continual in nature. And then outside from atomic, looking at it more from a systemic standpoint or across the system, you have things like integration and system tests, which we are familiar with. But then when we're looking at it continual, one of the examples that we talked about was chaos engineering. The example is out there about Netflix, where basically you're running a simulation. You're running a simulation. I at Papa John's, we have been running this simulation in stage. We have done some of the simulation related to disaster recovery in production, but we really run most of our chaos engineering aspects or chaos testing aspects in stage, where we are checking for things around availability, or basically how would a system react when we move from 3 nodes to 2 nodes because the system is unavailable, and things of that nature. So this is a gist of the dimensions of different fitness functions. It is not fully conclusive, but it gives you an idea what you're looking for, right? Basically, whether it's atomic or holistic, and whether it's something that has to be continual in nature versus being triggered at a given point of time. The way how these things could be implemented, definitely automation being right, front of mind, because what helps evolutionary architecture is speed, right? At the end of the day, something that you can validate fast, quickly, as part of the cycle itself, as opposed to something at additional effort, definitely helps to evolve the architecture faster, quicker, or make corrective actions quicker. So that's why CI/CD, like continuous integration, continuous deployment, is one of the great examples that can assist with evolutionary architecture. Um, organizing the team to meet the desired architecture is a very important concept. It is known as the inverse Conway maneuver. So you have to evolve your teams. I've seen that happen over and over again based on my professional experience, where you started with siloed units of organizing teams, to now in some cases you went to like an enterprise service bus team, so you had a shared services team, to now going to a microservice architecture where you have a combination of system API, system level teams that are domain specific. Then you have experience APIs, which could be shared across teams, or have a central team there. So there are multiple flavors where, based on how your architecture is evolving, you are able to reorganize the team. For example, DevOps is a very good example, right? We touched a little bit about deployment pipeline, but DevOps is a good example where many organizations, it starts as one team, and then over a period of time it turns into a practice where you have team members on individual teams continuing that DevOps practice, and then you're basically looking at a full organizational structure change, and you're able to kind of get that, lack of a better word, velocity and efficiency. Other things to consider as part of supporting practices is the appropriate level of coupling, right? So we talk a lot about modularization. So basically everything being a module on its own, standalone, independent of each other. Why? Because if you make a change, the impact is limited there. And then that way you are not really impacting the whole system. However, at the same time, you also have to look at a balance of functional cohesion where multiple modules need to work together to complete a particular function. So what that functional cohesion looks like, right? And then the last one, but not the least, is anything related to defining the boundaries of based on context. So how much of it is generalized context, which is basically applicable across multiple domains, and what really needs to be localized. You don't want your business rules, you don't want your logic to be living all over the place, right? But at the same time, you don't want to have the same rule in multiple places. So what would be that approach? And then that basically begs the fact is how well you're able to structure your domains. And then how, like for example of domains would be you have customer domain, you have the product domain, and so on and so forth, right? So what is localized to that domain, and then what is common across them, if there is anything common, and then you're looking at functional cohesion as to how they actually talk to each other. Is there a perfect recipe? There is no perfect recipe, but there is a general guideline of adopting the best practices. This is my joke around best practices. If everybody is adopting it, then are the practices really great, or are they mediocre, right? So I'll just talk a little bit about how Papa John's is trying to do it. And I won't say that we are perfect, but we have definitely seen improvements over a period of time. We have been doing this over the past, I would say, 3 years. From an architecture standpoint, it has been over the past 2 years. So we'll walk through it and we'll see how we are going about it, doing it. Again, it's not a one size fits all. Every organization is going to be different. But it's something that you would evolve into. So this is taken from from the we're following the disciplined agile workflow. So that's how we have been operating. So before doing enterprise architecture this way, we started organizing delivery teams in that fashion. We don't do all the delivery modes that are shown out here. We're basically doing continuous delivery, and we're doing agile delivery. And we're doing some aspect of program management. That is a discipline that is building up since the last year or so to help coordinate multiple agile teams that are associated with a particular program. For example, we are working on personalization, right? And personalization, you require personalization to be done across multiple channels, right? Your mobile apps, your web, you're talking about call center. So although it's a personalization program, it has to involve multiple teams, right? So how would you go about doing that? As a practice from enterprise architecture standpoint, we started collaborating with the product team very closely. And what has helped over a period of time is we have a pretty good business strategy in place, right? So we basically been able to work with a 1 to 5 year business strategy, which has helped us build a technology roadmap. And then we have basically been able to use that technology roadmap, work with our delivery teams, reduce them into smaller components of what that would involve in building out that particular roadmap or implementing that roadmap. And then we have been able to also work with the other part of the organization, which is operations and release management and the resiliency teams, to be sure that we have the tooling in place that we can actually monitor as these components are being developed, whether we are moving in the right direction. So all the data coming back to us from we term it from the development intelligence, from the operational intelligence, and also anything that is coming back from obviously from the business side, that's product management, ROI and things of that nature, or the sales numbers that we were able to derive, or the reduction in the number of calls that came in, or improvement in customer satisfaction, all that coming from the product side of the house. We are able to feed that back into our technology roadmap, and then just be able to reuse part of it that has been successful and change part of it that is not successful, but in an incremental fashion, right? So keeping that framework in mind, we have actually gone down the path with the help of product management to actually go out and build out our domain model. So we do have all these domains that we interact with as an enterprise architect team. We have delivery teams that work under these domains, that are organized under these domains. We have product owners, product managers that are self-organized. Now, there might be business units that actually work across these multiple domains or are responsible. But in terms of the work that we do and in terms of the roadmaps that we do, we pretty much are kind of looking at these domains on a continuous fashion, whether it is related to how things are evolving in the QSR space, which is the restaurant industry, our competitors, whether it's related to any technical debt that we are accumulating over a period of time, that is putting us at a point of risk that we cannot meet the business needs in the future. So those are some of the things. Along with program management, we work to basically formulate and educate the changes in the roadmap. We actually also have a technology roadmap score for any initiative that is recommended by business. That's a quick evaluation against our roadmap to say anything that the business is asking is aligned with the roadmap or it is not aligned. Now, if it is not aligned, then we talk through it to see if the roadmap needs to evolve or if it's basically a business idea that is not useful. So that's the way how we have been interacting with our business counterparts and in terms of bringing initiatives down the pipe. In terms of our solutioning and architecture part of it, we are a team of enterprise architects, solution architects, and domain architects that work together very closely. I'll move into the other slide that talks a little bit about how we interact with each other. But one of the artifacts that we create initially is known as a solution architecture workbook. It is very lightweight. It basically lists down all the dimensions that we talked about in the past. It has a section for data. It has a section for integration architecture. It has a section for high-level business requirements, talking about the stakeholders, all those aspects. It talks about what is the expected performance of the system in terms of SLA, tier levels, and things of that nature. And then we are basically working together to come up with an overall solution. And it goes through a process of vetting through the organization. And finally, it gets to an architecture review board where it is validated. So you have the different stakeholders for each of those dimensions, whether it's the chief of information security or the chief architect of security. Similarly, you would have somebody for the databases part of the organization, and so on and so forth, that approve and validate it. At the same time, then we are post-validation, we are now going through the build out of the product, where now you have, lack of better word, divide the work among all your delivery teams at this point, right? And that's where the domain architect or the domain solution architect comes into play, where he's able to work through that along with the teams to kind of build out their piece of the puzzle. And then you have the whole testing coverage, which is basically a way how we implement fitness functions. So you have the output requirements that have been stated in the solution architecture, and then the teams are following their agile processes and doing all their testing and through DevOps and all the other best practices of integration testing and unit testing and all those other aspects, you are just validating them as you are flowing through your solution assurance process, your software development process. We also term it as the bill of health activities, which we will take a look at it more closely in the next slide. But at the end of it, what you have done is you have verified that stuff that you have built is matching spec, right? And if it is not matching spec, then we basically document some kind of deviation, or we document the change in requirement. And that's how we basically track the evolving architecture over there. So it's a continuation back and forth process, but pragmatic in nature, so that we are still meeting our deadline, right? And then you have the final, final deployment and those aspects of release management and everything. This is a little bit about the governance structure. It is a little bit lightweight. So after we've gone through the ARB and we have looked at it, as we are going through the solution assurance process, we are making sure that all the bill of health activities, which is basically our own version and definition of the fitness functions, are being honored and are being tracked as Jira tasks, right? So that's what we use. We use Jira boards. We define our stories. We work on them. And then we're basically tracking the output, and then those stories are implemented across sprints, and then they finally go through release management, where there's a final sign off, and then the product is eventually released, right? So what are some of the pitfalls and anti-patterns, right? So every process is not bulletproof, but you iterate, and you basically do have a situation where all of us have been, where we have had to adjust and adapt and stuff. But these are some of the common patterns that I have noticed, and I have experienced, and I have been part of. And sometimes it's difficult to move away from it, but it's always good to acknowledge it and basically try to address it as we're moving through our implementation or moving through different projects, right? So the first one is a very popular one, has happened to me in case of ERP software and things of that nature, the vendor king situation, where you're coupling the organization very close to the tool, right? And that's not the way how you want to look at it. You want to basically understand what the tool is capable of, and then you need to understand where the organization wants to go to. Now, there are situations where some of the business processes need to adapt because it makes sense that the tool is recommending a modern way of doing things. But at the same time, you need to be able to figure out, rather than customizing the heck out of the vendor tool and making it difficult for future upgrades and future enhancements, how you can build around it, right? And try to stay pretty much within reason to meet the business needs, but at the same time, you're able to adapt and evolve and take all those updates and improvements that the vendor would provide over a period of time. The next one is more about not just jumping on new technology. We are all technologists. We like to, we are always attracted towards a shiny object. But being an architect, what I have learned, and especially an enterprise architect, before you recommend something, you need to try and test it out. You need to understand different components around it. If you're planning to change something related to a microservice framework, you need to look at aspects of security. You need to look at aspects of performance and all those other aspects. In some cases, you also need to look at retooling of the organization, right? So I call it the problem of using the newest toy, right? And trying to do resume-driven development as opposed to what makes sense for the organization and the team. The next one is planning horizons. So you have to plan in incremental fashion. It's very difficult when you're trying to plan too much in advance, or you're trying to plan whole lot of things in advance. You don't have time to revisit. You always get stuck with things like that stuff cannot change and this stuff cannot change. You have too much, sunk cost aspects to it. And that doesn't help us to build any evolving architecture, because you're not even challenging the norm at that point of time. So incremental planning is a very important part of evolutionary architecture that helps you to plan, replan, because your roadmap is evolving, your requirements are evolving, and that way you're adapting, right? And the last one is about code reuse. I'm a big fan of code reuse, but you have to be careful and weigh it out against level of complexity. If you do end up using a lot of code reuse, how complex you're making your system, and what is the balancing act across making it multi-purpose versus increasing the complexity of your overall solution. Um, yeah, so my recommendation, although not easy, is to keep evolving. It's about it's very similar to the agile way of doing things, but at the same time, you're still defining all your fitness functions in a way that it's guiding your evolving architecture within the boundaries of the realms, right? And you can challenge those boundaries too over a period of time. So say, for example, some of the boundaries get challenged to say, okay, the business today is okay with getting this data once a day, and then you, for reporting purposes, and then you get a new business requirement saying, now I want to report more than once a day. So what is that within reason? Now, do we need to jump directly to getting data in a real-time fashion? Can we get it like maybe now twice a day or once every hour? So what that architecture would look like, and what should our roadmap look like to meet that business need, right? So that would be one of my examples of evolving just from a data integration architecture. Yeah, that's what I wanted to cover today. These are some of the references. I think I should be able to share these slides too. If anybody is interested, feel free to reach out to me. I would definitely recommend this book of that is it's called Building Evolutionary Architectures, Support Constant Change by Neil Ford and Rebecca Parsons and Patrick Kwa. Very good read. Just a small piece of advice: when you go through this book, you might feel it a little more theoretical in nature because it does not have actually implementation examples. But I would still say it's pretty provoking, and it helps you think about problems in a different way. And like I showed you the example of what we are doing at Papa John's, which is kind of picking a lot of what has been talked about in this book, that would be something similar in nature that you would do. So it's not like a recipe book, but it definitely provokes your thought process and makes you think in that direction. Yeah, I'm ready for any questions.
So I don't see anything in the chat yet, but I have a question. And for context, I'm a relatively new solutions architect. My organization's gone through a lot of transition, and I've been in the role since March, but I keep joking that most of my team's focus has been on other duties as described and less so on standing up an architecture practice. So I'm very green, but I'm interested in when you've seen resume-driven development, because not just in this organization, but I think throughout my career, that's probably the anti-pattern I've seen most. Have you found a good way to counter that, or kind of channel that energy, rather than coming in like a police force and saying,
Yeah,
no,
I know what you're saying.
Yeah.
We see that it always happens mostly with newer team members when they join the organization or they have a switch in role, and we go through the rationalization of why they're recommending that particular architecture, or why they're recommending that particular development programming language, that particular standard, and what benefit are they going to derive. So if there is a worthwhile benefit, there is no reason for not doing or not going through that path of building a prototype, building a pilot, and making the business case. But however, if there is no strict argument towards the business proposition, we do talk about it as part of keeping an eye on evolving technologies, but we don't adopt it into mainstream right away. So that's the balancing act that we follow, so that we are not basically killing creative thinking, but at the same time we are not jumping onto every single technology that is showing up there just because it's a very good idea from that standpoint. So that is the balancing act that we have. We do build out proof of concept pilots if it is worthwhile to show that it is working. And then in some cases, it's like, okay, the product is supported in beta. And then we wait for it to become part of mainstream before we can recommend it for enterprise adoption and things of that nature. But I agree with your idea that you just cannot be a police all the time, but at the same time, we also make sure that if something is coming into mainstream, what needs to go off of the stack. So, because at the end of the day, you're trying to balance out a workforce, you're trying to balance out standardization as well. So, as an enterprise architect, you have to look at those aspects as well.
That makes sense.
The biggest one that has come up of recently is the Go language, right? So we are a Java shop at Papa John's. We have a lot of stuff that we have written in Java, but then there are tremendous use cases for it to be rewritten in Go. We have also already embarked on, Angular and things of that nature. So there is a lot of that going on, and we encourage the discussions through our architecture community. So although it's not in the realm of always talking about a particular solution architecture, we try to encourage ideas to be brought to the table and also challenge the norm from time to time. Because if we don't look at our standards from time to time, they pretty much get outdated. So that's the part that we need to keep an eye on as well.
Do you have a regular cadence that you set for reviewing standards, and do you have
Yeah, we
different?
do. Yeah, we do. We do. Based on what initiatives are coming through the pipeline, we definitely look at reviewing those standards once a month. And then we also have a way to look at all our standards, the ones that we have kind of defined and they have lived for over 2 years now. We start looking at them once a quarter and try to see even if they are applicable anymore or no. Because, for example, if applications have already migrated, we're no longer using that stack, because a lot of our stuff, as we're moving to the cloud, some of the standards that were defined for data center based technologies, we're kind of revisiting them and evolving them to whatever we need from a cloud service provider standpoint.
Okay. Have you been in other environments where you said Papa John's has a lot of Java?
Yes.
Uh, have you been in environments where it hasn't been mostly one language, where you'll have, Java, .NET, Python, all sorts of different things in the ecosystem, or has it usually been pretty monolithic as far as tech stacks?
No, it has in Papa John's itself, things have changed. So on the application side, we have had a lot of Java, but when we come to the analytics side, we always have had we have had differences there, different technologies, because we have Python, we have R also there. So we have been balancing out the fact of what's a better fit use case for certain kinds of languages and certain kind of scripting. Some of that stuff is also reliant on the resources associated with the projects as well. So we try to figure out a way how we can actually manage both of those technologies and stack, and what certain pieces of the puzzle can or solution can be built using a particular technology, like provide some guide rails there, guardrails out there, and guidelines to help with that approach. So we do see that being a pretty challenging environment when it comes to data science aspects, because there are multiple tools out there. We eventually will get to a point even in our application programming side of the house where just looking at some of the API microservice development, that be evolving into a multiple technology stack environment as well.
Great, great.
It puts a lot of onus and challenge on the architecture community and organization, so that we are not very single threaded, or we have enough talent that is basically able to adopt the technology, because you have to retool your organization as well as have a balancing act of hiring new talent. So growth mode always helps. So if the organization is in a growth mode, it definitely helps you to balance that out in a more effective fashion without losing too much time.
Yeah, that makes sense.
Any other questions? Nuggets anybody else would like to share based on their experiences? Okay. If Brendan, if there are no other questions, and I do see the numbers dropping, do you just leave the session? Is that
I think at this point, if we're wrapping up, we can all just leave the session, go to another screen.
okay? Awesome. Thank you so much, Brendan, for your help, and thanks to all the other listeners. Yeah. See you at other talks. Thanks. Bye.
Thanks.
Yeah.